Now coming to electrochemistry. In the previous video, we discussed about the terminology involved in electrochemistry. In this video, we are going to derive the Nernst equation. This Nernst equation is used to calculate the EMF of the cell at different concentration. Just consider E naught. This E naught represents the EMF of the cell at standard conditions. And what are the standard conditions? If we keep temperature as 298 Kelvin or 225 degrees centigrade, pressure 1 atmospheric pressure, then concentration 1 molar concentration. If we calculate the EMF of the cell by keeping this as like this, if we maintaining the parameters temperature, pressure, concentration, if we calculate the EMF of the cell, we call it as E naught. It is standard EMF for that cell. If we change any one of the parameter here, like if we change the temperature or pressure or concentration, we call it as E. It is not standard EMF because we are not measuring the EMF at standard conditions. If we vary any of these three parameters, that E naught will vary. Now we are going to derive this Nernst equation to calculate the E for any cell. If we consider one equation, thermodynamical equation, consider a reaction. A moles of A reacts with B moles of B, and now it is in equilibrium, and the products are C moles of C and D moles of D. Consider one reaction. Here A moles of A reactants with B moles of B, and the products here are C moles of C and D moles of D. Already we know that thermodynamic equation delta Z naught is Gibbs free energy, that is equals to minus NF E naught. The Gibbs free energy is equals to charge transfer, the product of charge transfer and Faraday's and EMF of that cell. Now delta G is Gibbs free energy at different conditions. It is minus NFE. Consider this as 1, consider this as 2, and now consider the another equation from thermodynamics. Delta G is equals to delta Z naught plus RT ln Q. Here Q is the reaction quotient. This is also thermodynamical equation. Now substituting equation 1 and 2 in 3, we get minus NFE equals to minus NFE naught plus RT ln Q. Here N is number of electrons transferred in that reaction, F is Faraday's, E is EMF of the cell at different conditions, and E naught is standard EMF, R is universal gas constant, T is temperature, Q is reaction quotient. Now minimizing this equation, it will give E is equals to E naught minus or T by NF ln Q. To write the reaction quotient, generally we write it as concentration of products divided by concentration of reactants. Now E is equals to E naught. If we are maintaining standard conditions, the universal gas constant is 8.314 and to temperature is, standard temperature is 298 Kelvin. by N. Farads is 96,500 coulombs into, to convert that exponential logarithm into natural logarithm, we multiply it with 2.303. To convert that exponential logarithm into natural logarithm, we multiply it with 2.303 into log, reaction quotient is products by reactants. So concentration of C to the power of C moles, D to the power of D moles by concentration of A to the power of A moles, B to the power of B. If we simplify this, it will give E is equals to E naught minus 0.0591 by N into log concentration of products divided by concentration of reactants. So by using this formula, we can calculate the EMF of the cell at different conditions. Now to calculate the electrode potential, if you consider anode, generally at anode, oxidation takes place. What is oxidation? Loss of electrons is oxidation. That means what type of reaction takes place at anode? Metal undergoes oxidation and it gives metal ion. To calculate the electrode potential for this reaction, simply we can use this as E is equals to E naught minus 0.0591 by N into log concentration of product. What is the product here? The ion, concentration of the ion divided by what is the reactant here? Metal. If we simplify this, E is equals to E naught minus 0.0591 by N into log concentration of the ion, because the concentration of metal will be always taken as unity. That means the concentration of metal is 1. Now this equation is used to calculate the electrode potential of anode. Now to calculate the electrode potential for cathode, first write that Nernst equation, E is equals to E naught minus 0.0591 by N into log concentration of products divided by concentration of reactants. Now coming to cathode, how can we calculate the electrode potential occur at cathode? Generally at cathode, reduction takes place. So what is reduction? Gaining of electrons is reduction. That means the metal ion in the electrolyte solution gains the electrons and it gives metal. So the reaction occurs at cathode is metal ion gains the electron and it gives metal. If you write this equation, Nernst equation for this reaction, we get E is equals to E naught minus 0.0591 by N into log concentration of what is product here? Metal. And reactant is metal ion. Just now we told that concentration of metal is 1. So concentration of M is, we will take it as 1 by concentration of ion. If you know the formula for log 1 by A, we write it as minus log A. So E naught minus 0.0591 by N into minus log concentration of Mn plus. So E is equals to E naught minus into minus plus 0.0591 by N into log concentration of metal ion. So this is the Nernst equation to calculate the electrode potential of cathode. And to calculate the electrode potential of anode, we write it as E is equals to E naught minus 0.0591 by N into log concentration of Mn plus. This is for anode and this is for cathode. So in this video, we derived the Nernst equation to calculate the EMF of the cell and to calculate the electrode potential for cathode and anode. Thank you.